Hello, everyone. Welcome to Patterns, Metadata, Templates, and AI. Oh my. What Andrew and I were from Action Lab and Ed Plus, and really what we want to talk about is architectural patterns, why they matter, how we're using them, and how you can actually, we'll talk about some lessons learned that we came up with that you can apply to your own work as well. So before we get started, the word pattern, and I didn't really realize this, and I looked it up and asked ChatGPT, you know, where did the word pattern come from? And evidently it's from the Latin patronus, which is father, and originally it was all about that model behavior, you know, people that exhibited, you know, behavior that you wanted to live up to. So that was the original context. And then in the Middle Ages, when you had guilds and craftsmen that started to come up, that's where the pattern became like a template. It was like, you know, if you're a leather worker, you had your templates as far as the shapes of the leather that you were trying to make. And so that's where it started to come, and that's where it started to get in the modern meeting that we want to actually have. But patterns are really, they're in nature. Nature has, I mean, they're all over the place. And so, I mean, we have seashells, you have, you know, similar patterns that are going, that coming together, snowflakes, neurons, you know, even the way we lay out our cities, there's patterns. It's not necessarily identical, but they're similar enough that you can actually build upon and create new things, or they're similar enough that you can like look at them and manage them in a common way. So patterns reveal structure, complexity. That's at its essence. It tries to make the complex simple. If you develop your patterns, and you know, but that's kind of our objective here. From a system standpoint, they allow them to really evolve and to be able to take on more work, because if you can actually create efficient processes by doing the same exact thing for similar types of work, rather than it being random and your systems aren't able to scale or manage, you know, the randomness of that work. And it's the same in nature, math, and code.
Yeah, so I'm really glad you mentioned code, since that's what I like to talk about. So let's talk about these patterns in system design. One of the big benefits of a pattern is that it's a definable problem. It's something that you're trying to fix. And once you fix it, at least once, whether through a tool or through a piece of code, you've created inadvertently a template. And when you operationalize that template and turn it into something that's actually solving that problem, you have an instance. And while this is a fairly linear relationship, pattern to template to instance, it forms a sort of internal feedback loop. And what I mean by that is none of these things exist in isolation. If down the line I discover that there was an edge case I did not catch, then I iterate on my template because the terms of my pattern are evolving. If I determine that there is some new functionality I need to add to the system, that changes my pattern and my template. We're constantly evolving. But the additional thing is that our instances don't act in isolation either. Just because I do something once doesn't mean I might not do something very similar again. If I make a second instance that's doing this, that's using the same template, well, I can just reuse it, right? And this creates that sort of like a consistency that John likes to talk about, because we're able to do things the same way every single time, and that's what a template's for. This is really useful in terms of data architecture because we're not, you know, creating redundant code, we're not repeating things, but as I'll allude to later, this is also really useful for AI. Patterns are something that AI feeds upon. It understands that logic and can build upon. We'll get back to that. Let's talk about the process again. So any complex process is you can reduce into a sequence of modular patterns, little pieces of problem that you're able to solve with code or through tools. The benefit of thinking about your code in terms of these blocks is that it solves a quintessential data engineer problem. If I ask two data engineers, how do I solve this problem, I'm going to get two different sets of code. And I do that again, and now I have four. And you cannot build a data ecosystem off of thousands of pieces of boutique code. But if we think about things in terms of these templates we're creating from patterns, then instead of having boutique pieces of code, we have a well, this iterative process that we can continuously draw upon. And then it doesn't matter whether you're asking me, you're asking John, you're asking anyone else on our team, we're always going to draw from the same modules and therefore have the same results. One of the things I think is really important to talk about here is that drawing back on that iterative loop, we're not trying to stifle creativity with this kind of consistency, because it's not static. We're constantly evolving. We're finding those edge cases. We're extending the functionality of what these blocks do. And over time, we're able to evolve them and express our creativity through how we change. One of the other things about it is that we're able to better understand what happens to our data. When you have these consistent blocks, when we have this cohesive system that fits them together like a tower, we know what the inputs are, we know what the outputs are. We're able to make sure that what comes in and what comes out are the same, and we know what's happening to our data down the line. When you have a monolithic block of code, you can get lost in the sauce, but when you break things up into these little iterative pieces, it becomes much easier to see at every stage what is happening to your data, and therefore if something goes wrong, where do I go to fix it? And how do I improve my process? So, turning it over to John.
So, when it started, we talked about the evolution of the word pattern, right, and the guilds, and really that's, and I think even within data architecture and systems architecture, it's the same kind of evolution taking place. We've all started the hand-built scripting, the SQL that does one thing only. That's how the natural, at least that's how I've always kind of developed SQL and jobs and scripts, but it does one thing. That's it. We started talking about templates, so you can templatize it. So like if you can have it be where you just fill in the blanks and be able to do it. And if you were in the hyperfile discussion, the session before, it was that kind of thing where you just fill in 5 variables and you can actually have a new data source for your Tableau file. That's all great, but that's all kind of you as the developer actually doing that work. Now, what we're starting to get into is more pattern-based architectures where the architecture itself is aware of those patterns and is able to create instances of itself in those same patterns, so you can actually create some scale. So as it needs to have, and this is where a lot of the cloud services. So if anyone's familiar with Kubernetes containers, it's compute that it's able to scale. Those are patterns, right? If you need more resources, it just brings up another container. You don't need that resource, it actually takes the container away. What's really going to be interesting is with AI, where does that go next? And I don't know if anyone has quite the answer, but we have some insight of where are some of these agents that are able to do some of these patterns and be aware, because as Andrew was saying, AI just thrives on patterns. And so the more we can think about patterns as that common language with AI, it just the possibilities are almost limitless. So the anatomy of a data pattern, just like any process, you have inputs. What are those? What's the data? What does it need to actually work on? Data doesn't come out of thin air. There's something that's producing it. So what is that? What's the process? What's that reusable logic that you want to apply to that data once you have it? What are those outputs? So what's the end state? What do you want to have coming out of this? And then there's been a lot of discussion today around metadata. What's the metadata needed to actually ensure that process and those inputs are exactly what are those data contracts on the inputs? So when this pattern actually does that query, the results that you're getting are exactly what you expect, not some randomness. That's part of a pattern. Is you want to ensure the quality coming in and out of these of your patterns as well.
And so how Action Lab uses this in practice is that we have our unified code library that we affectionately call Madlibs. If you ever used them before, you'll understand why. It combines DBT macros and Airflow operators into these sort of consistent parameterized template blueprints that we can use. If you were in the Tableau hyperfile segment, I showed off that to add a new hyperfile is usually as simple as adding 5 values to a configuration file rather than adding code. This not only reduces redundant engineering, it maintains consistency and lineage and governance across all our processes. One of the benefits of designing things this way is that we're in the template phase where we're able to articulate patterns that we're trying to solve and create templates that solve them. But as John alluded to, as we build out Madlibs and other sort of data structures within our team, we're trying to fill in the metadata gap. We're trying to understand not just how we solve the problem or what we're creating, but how all these things fit in together into a broader pattern ecosystem. So you can think of metadata as sort of the pattern language, because it's not just code, it's not just solutions and templates, it's how all those things fit together. It's your data sources, your data products, it's your processes, business logic, team members, your code. Metadata defines those relationships. It helps you understand everything that's happening across your data ecosystem, how these things all fit together. This is really useful as a sort of vocabulary for humans because now you can better understand, oh, these things flow into each other using this and create this. But it's also really useful for AI, and I'll talk about that a little more in a second. The other big thing about metadata is that this enables us to have better governance. We know what is happening where, we know what processes feed into what tables and what products those create. We have lineage, so we know exactly the tables that are used to create other tables. So everything flows together nicely. We can always explain what's happening at every stage in the process of our processing. So I've teased this AI thing too much, so I'll talk about it now. Action Lab has been working on this little chat agent we call affectionately Allie. One day Allie will use the metadata that we're building into our code base as context to understand our data pipelines and not just document them, but also audit and refactor and potentially suggest improvements to future iterations. As I talked about earlier, pattern development is not merely a single task, it's not a destination, it's a constant well we draw from, and our goal is one day to have something like Allie part of that process where it's constantly iterating with us, finding those edge cases, extending the functionality. The other thing I want to talk about in Allie that's important to metadata is Allie's awareness of data products like our reports and dashboards and tables, of which we make many. Many of you have used AI, I'm sure, and you know that it's really good at pulling data from reports because reports are primarily text-based. One of the problems that we've been trying to solve with Allie is how do we surface relatively invisible data products like a dashboard or a table where there isn't a ream of text explaining exactly what it is. And so Allie uses the metadata to understand the relationship between that dashboard or that table and the rest of the elements that were used to construct it and is therefore able to better surface it. So you can ask the question like, I want a dashboard about 21st day, for example. And even though the word 21st day may not never appear in the description of that dashboard, it understands from the context of the tables, it understands from the design documents that were used to create and explain that dashboard what it is and could potentially resurface that. We're still working on it, but it's doing pretty well. And the big benefit, I think, to this is metadata as a vocabulary is really important to humans, but it's so much more powerful in the hands of something that can understand this entire nested web of information. It turns the sort of individual knowledge that we all possess on the team about things that we work on into something institutional. A node-based glossary is how I like to think about it because it's connections between different elements that it can crawl in seconds when it would take us perhaps months to map out. But speaking of the future.
So patterns beyond Action Lab, and so these are kind of learnings that anyone could, we're offering as lessons that you can apply to some of your own work across any tool that you happen to work in. One is this pattern template instance lineage kind of construct. If you start thinking in patterns and those repeatable instances, you at design time, you can make those better decisions, so it saves you time down the road. Encourage teams to document and share their own design grammars, meaning the metadata. As your own team, make sure you're using the same vocabulary and normalizing. One of the things, even tagging, what are the tags that we should be doing to our research reports and our dashboards, and everyone has a different idea of what that is. Really synthesize it and come up with a common language for your domain as you're doing it. There's some ASU overall arching ones, but each area has their own vocabulary as well, what you call things, and how do you actually work? And then finally, as we scale, and scale is really, I think, as data professionals, we need to really be aware of, the amount of students that we have at ASU is, much greater than just about any other higher ed institution, and that's continuing to grow. So scale is definitely, we're leaning into scale if you really look across the different projects that ASU is taking on. So how can we actually do our part? And part of it, I think, is thinking in those patterns, repeatable processes. And just some closing thoughts. Patterns create that coherence, the commonality, and not just between you and your peers, but also your new peer. All our new peers, AI agents, right? We all have our own little mini me that is out there, or how do they interact in an effective way, and what are those boundaries that we want to govern that AI agent as well. Metadata is the context. We've spent a lot of time on that. Scale. AI creates learning. AI actually, we think about patterns. There could be patterns in your own processes, own data that you're not even aware of, and AI can actually distill those out and say, they'll identify the pattern, but it's going to be up to you to kind of figure out, okay, what does it really mean? What does it represent? And then really forming that architecture of truth, because at the end of the day, truth is really common knowledge and language, and that's all about patterns in this metadata. So we'll open up to questions. Thank you. Well, there's a lot, but.
Oh. I don't need a mic.
Okay.
We have a CRM that cosplays as a SIS, so like our marketing system, it really is treated like a student information system. And since our tribal knowledge is different by departments that use the CRM, do you have any words of wisdom for how we create patterns that eventually feed the coherence needed for an AI? Because that seems like a huge lift. And how do you deal with that and
So let me rephrase the question and make sure I got it. So with different departments using different systems lenses, how do they interact? How do we get AI to interact across of those?
Well, like we can't use AI because our data doesn't have, the architecture doesn't have coherence. So like moving that tribal knowledge in terms of
Yeah.
how they use the data architecture that's different by product.
Yeah.
And now we're trying to.
Well, yeah, and part of that is to find those common knowledge, like the things you can lean into, like whether it's ASU right or common identifiers, that is a starting point. The other piece, the other technique, and it's beyond really the scope of this, but there's a lot of work around ontologies, which is an ontology is it's a structure of language. So you can actually say, using our you have a table contains data, right? And so you actually have objects and what the relationships are. You can start mapping your language, and as you're going across different perspectives, those commonalities, the language, if you start to map the different languages, you can kind of come together as far as getting those concepts coming together. We in my past, we did that. We used that technique to go across banking institutions where each bank had their own customer file, right? Used different terminology of what a customer was, but by using that, it actually you can pick which perspective you wanted to see your data, and it will do that. Problem. This is 10, 15 years ago. The compute was difficult. It wasn't available. I mean, now with where things are at, it allows us to do that. So you're seeing ontologies coming back. And especially in the space of LLMs, it's actually adding more context to have better results. So we can talk more about that, but yeah. Jennifer.
Can you give me one example of a pattern?
So one of the things that we talked about, one of the examples that we gave in a talk about 20 minutes before this one is a Tableau hyperfile. So in essence, we want to load data into a packaged format so it can be served in a Tableau dashboard. The pattern that we came up as a team was a piece of code that takes SQL and runs a model through dbt, extracts that data, transforms it in memory so it meets the requirements of the Tableau hyperfile, constructs that hyperfile, then sends it to the Tableau server. So one operator is the Tableau hyperfile operator that does all these operations, but beneath that layer, there's also 3 modules, one for Tableau, one for Redshift, and one for in-memory processing. And so that's a pattern comprised of patterns. It's patterns all the way down to the base layer, but you can combine them upwards until they have this sort of template that executes a defined set of instructions. And because most Tableau hyperfiles will run in this particular way, adding an additional instance of that is pretty straightforward. That's, I think, a good example of a pattern.
Thank you. That's very helpful, very concrete. I was feeling myself floating off in the abstraction layers.
Yeah.
So what would I be missing if I said that is a modularized library of code? What am I missing?
I think that's analogous. Yeah.
Okay.
Yeah.
Old school.
Yeah. No. Right. Right.
Talking 90s vocabulary. I'm just trying to make sure I'm not.
Yeah.
Missing.
I don't think you're missed. So that is the modular code libraries. That's one form of patterns. I think by taking a step back, even within the code, we can develop patterns of patterns of SQL, patterns of Python, patterns, that you can then, right.
I guess like one example would be using that Tableau hyperfile is going beyond the modular library, even though it is relatively easy to spin up a new one, is what happens when through good metadata, good documentation, the pattern is we know that this process creates a hyperfile and we know the inputs that go into it. If I just told an AI agent, hey, I've got these inputs, it would be able to construct that pattern on its own. That's the next level. It's not just about code for developers. It's about the metadata and relationships between the data products, that code, and the data sources, such that as we work towards it, we're able to more efficiently operationalize that pattern, not just in terms of the code, but in terms of its place as a pattern within the greater data ecosystem of what we're doing.
Let's talk good metadata. How are you QAing what is good metadata? How do you analyze and remove synonyms, polysemy, other things that interrupt large language in order to bridge between these different data sets, even in your Hyperion example, or your example you just used?
So I think it's within the domain that you're looking at. My question, can I ask a question? But why would you get rid of synonyms?
Not necessarily get rid of them, but bridge them together.
Bridge them together, yes, because that's one of the techniques that, to our question of how do you develop synonyms that goes between different.
Yeah, we don't want to get rid of them.
Right,
That creates
right.
authority control. We don't want that.
Yeah. It's really around it's the use case that you're looking at is where you got to start.
If you get almost no metadata, minimal.
I think you have metadata just from the nature of the code. I mean, that's a starting point. But beyond the technical, yeah, oftentimes you don't. And that's where you need to, fill in the blanks, take a stab at it. And you have a
Yeah. Well, I think one of the benefits that we have as a team is that Action Lab generates reams and reams of reports. And so part of our relationship metadata building is lucky in that for any given data product, there's likely at least a 1 or 2 pager that we can draw from. We can extract metadata from that to build the initial glossary and then iterate from there. It is difficult in the case where you don't have anything to draw from. So in the case of dashboards, we do have our analysts going back and thinking about the kind of questions that, for example, a dashboard would solve to just create that initial impetus directional data for metadata.
Using that, I'm just thinking about your use case here. Because we have those reports, we're able to, if like a Tableau dashboard, we may not know anything about that other than what the dashboard is. But we can go and there is a report, a written narrative around that. We can use that to extract metadata around, and then AI is actually pretty good about drawing the connections. If you tell it these two things are related to each other, right? That may help if you have some documentation off on the side. It will not, AI can look at your code, look at your documentation, and then draw some correlations. You still need that human in the middle to validate, but that may be an approach for those unknowns, those unknown unknowns, right? Was there a question in the middle here? Okay. Well, thank you. We'll be at the front if there's anything else. But thank you for your time.